All right, so this video is about lesson 3.6. We are transforming cubic equations. And the good news is that all of this stuff is the same thing that you did from chapters 1 and chapters 2, where you've got f of x transformations and you've got x transformations. So what I mean by that is, like, are you adding, subtracting, multiplying? What are you doing? Is it to the function, or are you just affecting the x or not? Okay, so let's take a quick look at all of your f of x transformations. That's where you simply add or subtract. That's going to move it up if you add. It's going to move it down if you subtract. If you reflect over your x-axis, you're multiplying the function by -1. So if you got your highlighter out, I would go ahead and highlight that. The vertical stretch and shrink, all you're doing is simply multiplying by a number. If that number is greater than 1, then you're going to stretch it. If it's between 0 and 1, then you're going to shrink it. But you have to pay attention to the fact that all of these things are multiplied to the function, not just x. So let's talk about x transformations. These are tricky. You have to have parentheses in all of these transformations. So if you want to move something left or right, you have to put parentheses around the x. So you can see right here, if you want to move it to the right 3, it's got to be x minus 3 in parentheses. If it's not in parentheses, it's going to shift it down 3 places. Okay? If you're going to reflect it over the y-axis, you have to put parentheses around your x. The negative goes inside the parentheses with x. Horizontal stretch or shrink, same thing. If you're multiplying to just the x, it's going to be very obvious because it's got parentheses around it. So you got parentheses around the x. So if you see that you're multiplying x times 2, you got to make sure that you use the reciprocal because it is specifically a horizontal stretch or shrink. So if you see it's multiplied by 2, it's multiplying it by a factor of 1/2. If you see it's multiplied in your equation by 1/2, that means that your factor is going to be multiplied by 2. It's going to have a stretch effect. So you need to be very familiar with all of the parent functions, but specifically for this lesson, you need to be familiar with x to the third. And we just did this in Desmos, where you start with the origin. You have a point at 1, 1, and you have a point at -1, -1, and it's got that up coaster type of pattern to it. So if you look at this example right here, as students, you need to be able to look at an equation and tell me what's going on, and you need to be able to look at the graph and tell me what's going on. So I'm going to grab a highlighter, and I'm going to highlight this +5. And then a different highlighter color for +2, because these are going to do 2 different things to your graph. So the +5, do you see how it's added to the 5? It's different if it's added to the, if it's added to the x in comparison to f of x. So I'm adding to x here, that's going to move it to the left 5. If it wasn't in parentheses, it would go up 5. The +2 is not in parentheses, so that's going to go up 2. So if you look at the graph, you guys know, you're familiar with the parent function. You know that it actually crosses at the origin. You know it crosses at this point. You know it crosses at these 3 points right here, and you can see, you can track it going left 5 up 2. So left 5, 1, 2, 3, 4, 5, up 2. You see where it wound up? So visually, you can verify that that is exactly what happened. Okay, bottom left hand of page, you've got this new one right here. Notice how nothing is being added or subtracted. So I'm not going to move anything up, down, left, or right. So I'm seeing 2 things. A lot of people want to highlight the negative and the 1/4 in the same color. They are different things, so use 2 different colors here. So the negative, what that negative is going to do is it's going to reflect it. We're going to talk about how in a second. And then that 1/4 is going to do something completely different, okay? So the negative is going to reflect. Let's write that down. So we're going to reflect, and we're going to reflect over the x-axis. How do I know I'm reflecting over the x-axis? Because it's in the front. If it was the y-axis, it would be inside the parentheses with x, but there's no parentheses here, okay? So what about the 1/4? Same thing. There's no parentheses here. That means it's going to be a vertical shrink, and it's a shrink because it's a factor of 1/4. No parentheses. So everything is affecting the function, not just the x variable. And you can kind of look here, you can see that it has flipped, reflected over the x-axis, and it has been like kind of squished vertically by 1/4. All right, next one, I've got two things. I have this 2 right here. It's in the parentheses, so that makes a big difference on how it changes my graph. And then I have a -3 here. So the easiest one to look at is the -3. That -3 is going to make it go down 3 units because it's not in the parentheses. So it's going to go straight down 3 places. The 2 is in parentheses. So it's going to be a horizontal blank. Now I'm not going to answer that whether it's a stretch or a shrink yet, because I need to determine the factor. Now remember, if it's a horizontal stretch or shrink, you're going to use the reciprocal of what you see. So I see in the equation I'm multiplying by 2, but I'm technically multiplying by a factor of 1/2. You've got to use the reciprocal of that number, and if you have a factor of 1/2, that means it's going to be a shrink. That is the most difficult transformation. So if you're getting the horizontal stuff, then you're doing a really, really good job.